Hello, everyone. My name is Yalda Nile, and I want to start our presentation today for our final project, which is environmental sound classification in hearing aid. My teammates are Erfan Zavare and Mushkan Asgarzadeh. Today, at first, I want to talk about why we chose this topic, what was the problem, what methods we try to use to solve it, and our data set. And my teammates are going to come and talk a bit more about the methods we used and the results we got. So first of all, the definition of the problem. Based on a report in 2012, approximately 15% of American adults, which would be around 37.5 million of them, who are aged 18 and over, report some trouble hearing. And most of these people need to use hearing aids. But different acoustic environments require different hearing aid settings to achieve the best sound quality. But manual adjustments of hearing aid settings can be annoying. So nowadays there are some hearing aids that automatically classify the acoustic environment and switch between different programs accordingly. So in this project, we're going to design a supervised machine learning model that classifies different environments based on their sound file. The method we used was, at first, we took the input data, which we're going to talk about later. We're going to talk about our data sets, but for now, we took the input data by defining classes to read data and pre-processing. We converted the audio file to image, and we used feature extraction. Then we used we tried different machine learning algorithms to train our models. My teammates are going to talk a bit more about each of these classifiers and what they do. But for now, to just get to know them, we can take a look at this list. There are some classifiers like K-neighbors, decision tree, random forest, so on and so forth, to ANN and CNN, which we got familiar with during the class and our assignments. And then we got to some results by comparing the models and selecting the best results we could have. Now the data sets that we used is the ESC data set, which is a freely available collection of short environmental recordings, which is presented in a unified format, which is 5-second long clips, specific frequency, and some other information. All clips have been extracted and manually labeled by the author from public field recordings. And in this project, we're using ESC50 dataset, which is a labeled collection of 2,000 environmental audio recordings. It has 5-second long recordings organized into 50 semantical classes with 40 examples per class. And it has 5 major categories, which are animals, natural soundscapes and water sounds, human non-speech sounds, interior domestic sounds, and exterior urban noises. Now my friend Mushkan is going to start talking about the pre-processing and the steps we took there. Thank you.
Okay, hi, my name is Mojgan, and I'm gonna talk more about our methodology. The first part of our method is about data pre-processing. We have 2 approaches for this part. The first approach is convert the audio file into image. And the most common approach for classification of sound is to convert the audio file to an image. and then use the model to process the image. Audio can be represented in the form of visual image by converting it into a spectrogram, which is a visual representation of the frequencies of a signal, and it varies with time. You can see here in this picture, this is the frequencies of an audio file that varies over time, and this picture shows a spectrogram of this signal. And we can see from this spectrogram whether there is more or less energy at each signal, and so we can see how energy level varies over time. So first of all, we need to convert the audio file into PNG format image, and we use LibRosa Python library to extract this spectrogram for every audio file. And the second part of our data pre-processing is feature extraction. Every audio signal consists of many features, which is frequency-based feature, and we should extract the characteristics that are relevant to the problem we are trying to solve. For example, for this project, we use MFCCs, which is a small set of features which consistently describe the overall shape of a spectral envelope. We use a spectral centroid, and it indicates at which frequency the energy of a spectrum is centered upper on. In other words, it indicates whether the center of mass for sound is located. And also we use zero crossing rate. Is a very simple way for measuring the smoothness of a signal, is to calculate the number of zero crosses in within a segment of that signal. RMSE is a value, is a root mean square error for each value for each frame from the audio sample. And also we use chroma frequencies, in which we can measure how much energy of each pitch class is presented in the signal. And also we use a spectral roll-off, which is a measure of the shape of the signal. And also it represents the frequency at which high frequency decline to zero. And this picture shows a spectral centroid for one of our audio files that I showed you in previous slide. So after data pre-processing, and the next step in our method is to train supervised learning algorithm, to train our model, and we use supervised learning algorithm. We have in our data set, we have an input variable that consists of labeled training data and a desired output variable. So we choose supervised learning algorithm that makes prediction based on a set of examples. And this supervised algorithm is an algorithm to analyze the training data to learn the function that maps the input into the output. And the purpose of this study is sound classification. And when our data are being used to predict a categorical variable, our supervised algorithm is called a classification. And also we have more than 2 categories, so our problem is multi-class classification. And there are a lot of algorithms that we can use to train our model, and we choose, and this table shows the algorithm that we used in this project. For classifiers, we had 2 approaches for this project. The first approach was just using feature that we extracted from the audio file and train the model. And the second approach was to convert the audio to image and get the result, and train the model and get the result. And also we have 2 other model, NNA and CNA. The difference between these 2 models is for NNA we just use feature extraction, And for the CNN, we use a spectrogram to train the model. And the next step, our methodology, after training the model and get the result, we should do some comparison between the model and select the best result. And there is a lot of papers in our literature review that use lots of algorithm, supervised, unsupervised algorithm, and they had some criteria to choose the best model. For example, accuracy, training time, and ease of use, for example. And based off those studies, the main criteria is accuracy. So we choose accuracy to choose the best model and suggest that algorithm and that model for sound classification. And next, Erfan gonna explain more about our results and talk more about it.
Okay. Thank you, Mushkan. This is Erfan. So after finishing the pre-processing and getting the input data ready for both feature extraction and spectrogram cases, first we chose from some famous classifiers libraries to train some models and calculate their accuracies and performances and make a comparison with them. As you can see, we use a random forest classifier, and we use XGB classifier, which is a gradient boost decision trees, which has a better speed and performance compared to the decision tree classifier. We also use SVM and K-enabled classifiers, which we've learned during our lecture this semester. We also use linear discriminant analysis, or LDA, which can be used to find a linear combination of features that helps us to classify our objects here. We also use Gaussian naive Bayes. We know that one solution to extend naive Bayes to real valued attributes is using a Gaussian distribution. It's really easy to work with this because we only need to estimate the mean and standard deviation from our training data. We also tried decision tree classifiers and quadratic discriminant analysis. The difference between the quadratic and linear is they are almost similar, but instead of using linear combination of features, we use a variant of LDA, so that an individual covariance matrix is estimated for every class of objects. We also had AdaBoost classifier. As we were trying XGB classifier, we ran into this classifier as well, so we thought to give it a try. And also, so as you can see, these results are for the feature extraction inputs. And the best accuracy and performance results was for the random forest classifiers. Same for here. I mean, as you can see in feature extraction, we have a better performance and accuracy comparing to the results from the spectrogram instead of like audio features. And the reason we did this was we wanted to see how these classifiers would perform with the spectrogram instead of using the audio features. And in addition to reduction to the accuracy, it also worth to mention that the time-wise performance was really poor, like 50 times slower. After finishing assignment 5 and getting familiar with the ANN models, we tried to replicate the same concept with our project to see if we can reach to a good result or not. The accuracy was almost like the best accuracies of the classifiers we used in the last slide. So we have like 48% accuracy here, which is almost same with the random forest classifier accuracy that we have here as a 49.5%. And we didn't stop there, so we tried to go a step further and learn the basic of using convolutional neural network, or CNN, to see if we can improve our model performance or accuracy or not. And we finally could reach to 65% total accuracy with this CNN model. So for the conclusion and lesson learned on this project, we encountered some challenges that they were like noise reduction problem and overfitting. For the noise reduction problem, at the beginning of our project, we were thinking to apply some filters and noise reduction methods on audio files before we use them as an input to make sure that the processed input data is good enough for our model to reach a better accuracy. But when we were trying to apply these methods on some of the audio files, which the noise was too much or the nature of the sound was noise-based, like wind or vacuum cleaners, it would cancel almost the whole audio file. That's why we decided to use a spectrogram and feature extraction methods directly on our audio files. And also for the overfitting problem, as we can see in the previous slide, our CNN model started overfitting from after like 20 epochs. So we tried to change the size of the training data set to close this gap between the training accuracy and the validation accuracy. But this is the best result we could reach so far. Also, we discussed about the ethics issue that might happen with these kind of projects. In our project, the data was only environmental sounds, but in the real life project, like the one that we were thinking to use for the hearing aids, we need to use the audio files that might contain personal conversation or information. We must make sure that these data will be anonymous and encrypted, so there would be a small chance of privacy invasion. Also, for the future work, we think about a couple cool subjects that we can follow, like we can have more than one category per object. For example, we can have a dog and a cat in the same file. How can we classify these objects? Also, we have another option, which is binary categorization. Is like we're saying that is this file is a noise or not? This kind of classification can be useful when we are trying to reduce the sound volume when there are we have a pure noises. For example, there is a sound of like a vacuum cleaner, and we want to like reduce the volume as much as possible during that time. We can also see if we can make an unsupervised model. So the project that we've done, it was a supervised model. So we can try to develop unsupervised model to see if we can like adopt each case's specific environments that they are in and classify based on their lifestyle. So it's kind of like localizing the classifications based on the subjects. And that was it. I hope that I mentioned everything. If you have any question, please contact any of us. And thank you so much. Thank you, everyone.
Thank you.
Bye. Thank you.